Welcome to Study Loop.
So we need to find the range of object distances when we have two given image distances. So one of the image distances, let's call it max. So that's the bigger one, which is 208.2 millimeters. And then the smaller of the two is 200 millimeters. So define that as di mean. Now from equation 23.8, we see that this is the relation between focal length and object distance and image distances, and we're given the focal length as 200 millimeter. So from here, if we solve for DO, we get F times DI divided by DI minus F. Now to get the minimum DO, what we can do is we can take the maximum over here because we see there's a subtraction, and if we take the minimum value, we see that if di minimum and the focal length are equal. So if I take the minimum value, that means this guy becomes 0, so the whole thing becomes infinity. So we don't want that. We want the other one, which will be smaller. So if we take this value, then we'll have some finite value, and which will be lesser than infinity. So that's why for DO minimum, we take the maximum value of DI, and we do the same thing here. And then if we put the numbers, it's 200 millimeter times 208.2 millimeter divided by 208.2 millimeter minus 20 millimeter, which gives us our object distance as 5078 millimeter, which is, let's say, roughly equal to 5.1 meter. Now, as we discussed earlier, to get the maximum value, we take the minimum di. So that's going to be f di minimum divided by di minimum minus f. And since both of them are 200, so we have 200 millimeter times 200 millimeter divided by 200 millimeter minus 200 millimeter. Now since we have 1 over or some finite number over 0, that means this guy becomes infinity. So our max value is at infinity. That means the range of d0 will be lesser or equal to infinity to greater or equal to 5.1 meter. Thank you.